Okay, I'll let a couple of people sit down and then get started in a second. Sounds good. Oh. Okay. Can people hear me? Does it sound good? Fingers up at the back. Thank you. Okay, so we'll get started. So I'm here to talk about managing containers, managing container configuration with metadata. I'm hoping that this is sort of going to be relevant to everyone either today, because you're using containers today, or in the futures, because you probably will be then. I'm Gareth Rushgrove. I'm from the UK. You can probably tell from my accent. I'm Gareth R. pretty much on everywhere on the internet. Tell me what you think of this afterwards. Up front, I work for Puppet Labs. Puppet's great. Puppet Labs is great. I'm not here to talk about Puppet today in this keynote. If people want to talk about Puppet, come to us in the Puppet room or the Contributor Summit tomorrow. I'm hopeful that this will just be sort of interesting to everyone. So, one of the things about containers is that containers are really cool. Like, who doesn't like shipping containers? James doesn't like shipping containers. Shipping containers are like, there's actually, the metaphor that tends to be used when people talk about Docker and talk about Rocket is a really interesting one, and I'm going to sort of riff on a little bit. Because actually, containers are not cool because of boxes. They're actually cool because of paperwork. And everyone loves paperwork. But somehow the people prefer boxes to paperwork. Finding the paperwork is actually way more interesting when it comes to managing systems. So a couple of examples of that from the actual shipping container world are the idea of a manifest. I'm not going to read these out. You can find other descriptions on the internet or read them yourselves. But the idea that there's this fixed document, this one thing that is very well understood, very well standardized across the entire world of shipping containers. The idea that a bill of lading is a document issued by a carrier which details like what they're carrying, and it has like legal standing in loads of jurisdictions. Like someone's done loads of work to basically decide what's in that document. And I'll come back to why that's useful and interesting and applicable to the management of systems and the management of containers in particular as we sort of go along. But bear that sort of high level bit in mind. So the talk is basically going to involve some introductory bits and pieces around sort of like the primitives that are available in containers today. I'm going to sort of diverge a little bit into why system packages are actually still really cool. I'm going to do some demos later on and then hopefully give you some homework and some ideas to play with. But before I do any of that, I'm interested in who in the room has played with Docker or any of the container runtimes at all, like you've typed Docker run. Good number of hands. Keep your hands up. It's the morning, good exercise. Keep your hands up if you've gone past that. You're now running in some sort of production thing. So still a bunch of hands up, but definitely less. Let's say there were 80% of the hands up to start with, and now there's about 10% of them left. That's sort of what I expected. And I'll hopefully the people who've tried Docker will be and tried some of the other tools will be familiar with some of the bits I'll talk about, but maybe not all of them. We'll see. So, if paperwork's interesting and we want to apply some of that ideas to like our software containers, what have we got to work with? Where can we store our paperwork? So, one of the areas is labels. Labels seems to be the word that has captured this in sort of container land for different implementations. In terms of Docker's got lots of places we can put this. So basically, we can attach labels to engines. So whenever you start up a Docker engine on a node, you can pass it some labels. That might be useful later, when you're scheduling containers to different nodes, maybe you want to schedule a container only to a node that has like an SSD disk, or has some other like known at start of engine like sort of metadata. We can also add labels to Docker images. So basically, as part of the build process of an image. So within the Docker file or the Docker file API, basically we've got the label keyword. Just a word of warning, sort of getting a bit ahead. Don't do this. Like this totally works. This is totally valid Docker file syntax. However, it will create a new file system layer for each of them, and at some point you'll run out. And I think one of the things that this doesn't happen that much yet because people are not really using labels and metadata that much. I think if we're going to build operational tools on top of containers, labels are a really good hook. And actually what you should do is this, which is slightly like basically we've only got one label and we've got multi-line stuff. So if we start doing that early, we probably won't run into weird bugs around going like, oh, my file's no longer build because I've added too many labels, because I've added too many layers. So word of warning. Adding things is like literally half of the problem. We want to get them back out again. And so the Docker API and the Docker tools allow us to do that. So inspect will output a whole bunch of information, and we can filter that for different things. But we can get the hash of labels back, and we can get that from the API. So as part of our Docker file, we can build images. They get some metadata. We can pull that out later to do stuff. And I'll talk about the stuff we can do later. We can also add additional labels at runtime as well. So at this point, we have an image. It has some metadata. That can be reused as part of like that running container. But we can also add additional at runtime metadata. So that's handy. And all of this metadata we've added, we can already immediately use using the native tooling. I think it's one of the reasons why I think people are not doing that much with container labels yet is because this is pretty much all you can do. We don't have the rich set of tooling on top yet. You can sort of put them in and then query for them. That turns out not to be very interesting, but it's useful. So I'll show you what you can do. So you can filter the list of images, for example, in this case, by the label com.example.isBeta. So as you start building up a fleet of containers, being able to filter them becomes increasingly important. You're running 10? Just list them. You're running 10,000? Probably not. And we can filter containers as well as images. You probably have more containers. This sort of becomes more useful. But it's not just about Docker. There are many different sort of competing bits of software or friendly bits of software that are in that space. Some of them concentrating on the container. Some of them maybe concentrating on the container ship, which is a terrible metaphor. But Kubernetes, as a good example, Kubernetes also has labels. They're slightly different because software. But ultimately, Kubernetes labels allow you to add completely arbitrary key value pairs to basically any resource within Kubernetes. So rather than Kubernetes having sort of been focused on the container in the Docker world, Kubernetes is focused on replication controllers and services and pods and other resources. But all of them carry around this arbitrary, completely user-definable metadata. So we can put anything in there, and that's true of the Docker labels. And I'll come back to that. That's good and bad later. And again, once we've added it, we can also get it back. So list, get me all the pods with where the environment, where's your key value, etc. So there's some set stuff, aura qualities. We can do things there. And the AppC container specification. I'm not going to go through all possible container technologies, but most of them have something akin to arbitrary user-definable key value pairs on their default primitives. So the AppC spec defines both annotations and labels. There's some confusion about why you'd use both. They do have sort of separate use cases. But I think it's enough to go like, well, all of these things are coming to the same conclusion that having arbitrary metadata assignment for users is a good thing. But I mentioned that like there's not a massive sort of like agreement on what to put in there, and that's the thing is like that we've got somewhere to put things. What do we put in there? You can put anything, and so there's sort of a paralysis situation there. And one of the places I want to look at for ideas for why would we put things in there are packages and package managers. So this is like the not container bit, because I think some of the problems that we have in operations have been well solved, but previously in packages. But some of those capabilities that we have with packages are missing from containers. And actually, the missing secret sauce is metadata, in my view. I really like system packages. Some people don't. I'll avoid like any disparaging comments or war of words. Cool. Someone's saying can't quite hear. So I'd argue that the power of system packages lies again not in the file format. Oh look, it's a tar file. It lies in the metadata that goes around that allows tools to be built up. So whether it's dpackage or whether it's RPM or whether it's Homebrew or whether it's any of the other sort of package formats, they often have some specification. They'll often also have a guide. Who's familiar with this document? Who's read all of it? It's somewhat epic, as is the Fedora packaging guidelines. But there's loads of hard-earned wisdom in these documents. I'm not recommending you go necessarily read them, but at least if you buy my premise, there's a lot of good stuff in there that I think maybe could be written with less words. Packages I say like that, yes, there's a tar file. Yes, there's the things you want in the package, but there's probably also some metadata. So whether it's an RPM spec file, we can see, well, it's key value pairs. And one of the differences between where something like this is today and where the container metadata stuff is today is there's agreement. Spec files have a summary, they have a name, they have a version. There is a schema for the spec file. You like if you don't provide the required fields mandated by the schema, your package doesn't build. The labels at the moment are arbitrary places to put anything, and so there's a subtle difference there. But again, we're just defining like key value pairs. We're defining like the name, we're defining a version, we're defining whatever. Why are we doing that in the first place? What's the purpose? Why is my package not going to build if I don't have that? And the reason is the tooling that is built on top. So this invariably blows the mind. Often so basically I work both as a developer, as a systems administrator, and there's often sort of pushback from developers who are less familiar with system packages about like, why do we need to system package everything? And the answer is because the tooling on top of that is amazing. And showing them the capabilities that you have if everything is from system packages tends to go like, whoa, I hadn't thought of that. So boring things like listing all the files from a package when it's on the machine is super useful. There's an arbitrary file on disk. Where did it come from? Let's ask the package repository. Finding unmet dependencies, finding like just mapping dependencies, finding the documentation for an arbitrary executable. It's all there based on this metadata, based on this catalog of package installation. We've got these tools that I think probably people in this room are familiar with. They use them like you jump on a machine, you want to know something about it. You can find out a huge amount using the tools built on top of the package metadata. One of the things that I think, if we're jumping ahead, what I'm getting at, what I'm hoping for, is a similar set of tooling around containers. So what would that look like? And my point is that I think we need metadata standards to get there. So let's talk about that a bit. One of the things in this space are the official label guidelines. And I think it's interesting to sort of dig into some of the specific guidance and compare it and contrast it a little bit with some of the details from things like the Debian package guidelines. So there's a fundamental difference in approach. So the Docker guidelines, there's very few of them, so I can actually put them all on slides without running out of time. Definitely couldn't do that with the Debian guidelines. But there are also things like all third-party tools should prefix their keys with reverse DNS. So this is, because it's arbitrary, it's an arbitrary key value pair set system. It's not, there's not a schema, there's not a fixed set of things and then somewhere to put other arbitrary bits. So it's all much higher at a higher level. You have to use reverse DNS, but like use one you own, and don't use the Docker one. It's sort of like repeated a bit. It's like, please don't use ours. You look like you're official, and we'll have to sue you. Keys should only consist of lowercase alphanumeric characters and dots and dashes. Note that that is a guideline and not imposed by the tool. So you can totally have things like uppercase letters in your labels, and it will totally work, but the guidelines say don't do it. Maybe that should be in the actual imposed by the tool. Then you wouldn't have to have the guideline. Key should start and end with an alphanumeric character. Again, it's all formatting. It's all syntax. Don't put too many dots in your labels. It's not about a schema. It's not about agreement. It's literally just stylistic. People's labels should sort of look the same. That doesn't, in my view, lead to interoperability. It doesn't lead to interoperable tools built on top of that agreement. Just knowing that something is lowercase and DNS prefixed and doesn't have too many dots in it doesn't allow me to do very much on top of that as a toolsmith. The sort of good and bad news here is that from a somewhat arbitrary search of GitHub and for Docker files on some of the Docker Hub stuff, less than 20% of the ones I had a look at followed these guidelines anyway. So there's 6 or 7 or so guidelines. They're not arbitrary, but basically they're all stylistic, and most Docker files don't follow them. Yay, success. Again, comparing and contrasting that with the package metadata with an RPM spec file, the package doesn't build unless it matches the schema. And again, without complete and consistent and agreed upon metadata, within whatever context that might be, you might just have, like, agreeing upon metadata within your organization would allow you to build tools within your organization. Agreeing on metadata within a community of practice that spans organizations would allow tools to build up around that community. That might be the Chef community or the Puppet community or the Foreman community. Agreeing on standards more broadly, globally, allows us all to have interoperable tools. So there's value in agreement at all levels, and the more grandiose we get, the more interoperable tools we get. That sounds a good thing to me. And without consistency, we can't build, we can't share tools, and we'll reinvent the wheel a lot. I prefer we didn't do that. So some of the ways we can sort of start fixing that are, there's already some tools out there. One of them that's really nice is the Hadoland, which is basically a Dockerfile linter. There are a lot of Dockerfile linters. Lots of people have thought about this problem. I'm not going through all of them because most of them are demos. I'll be polite. Dockerfile linter, Hadoland is actually excellent. It is written in Haskell. And as Mark was talking about Haskell yesterday, I think the keynotes have to mention Haskell. That's the law of config management camp. That actually has some interesting side effects, and this is sort of an example of some of the output that you could get from a Docker file. Some of them are just things just like practices. So just saying from Debian, well, that changes over time. That's a bad idea. So Hadolin says, well, that's totally valid, but don't do that because you will bite yourself in the foot when there's a brand new version of Debian. Your builds are now different, and you were surprised by that. So, hey, remember to say you want Jesse, you want this specific version. Hadolin does some other quite clever things, specifically using the shell check, basically a static analysis tool for bash. Because Docker files basically have some keywords and then invariably some bash. Hadolin actually goes into that bash and goes like, hey, that bash is completely syntactically invalid, or hey, your variable names are different. The example here is that it's picking up on, well, you referenced a version called, a variable called node variant, which you haven't assigned. It's also picking up on you have got one called node version, maybe you meant that one. It's like, ooh, it's like the Elm compiler that tells you what you did wrong, not just that like it's broken. So Hadolin is excellent. It's very focused but quite polished. There's a web UI. You can just run it locally if you're happy with compiling Haskell. So another a sort of slightly different approach is a tool I built, and I'll show a demo of this in a second. Basically, Docker Label Inspector. This isn't a particular polished product, but I think they're like the ideas are part of this sort of narrative that I'm building. Some of it is literally just linting. Again, basically taking the Docker guidelines and turning them into code. Honestly, Hadolin does that much better. I think I wrote this before, like they shipped Hadolin, but I totally use Hadolin instead of that. More interesting in this context is something that I was doing with the same tool, which was actually validating labels based on a schema. So in my case, I picked a JSON schema. So hopefully the text is big enough on this massive screen. But actually, just using, if labels are just key value pairs, well, we can interpret that as a JSON structure, and we can use a JSON schema to enforce rules there. So we can bring typing to arbitrary key value pairs. We can bring specific formatting. We can bring requirements for certain labels to be present. So whether that's an organization schema, whether that's, again, a community schema, whether that's a global schema, we can block on like your labels being present. You can't build an image without the right labels. And we're back to that world of building packages. So I'll do a quick demo of that if I can get this mic. Oh. Turn off mirroring. Hopefully that's going to be big enough. I can go a bit bigger. There we go. Is that big enough? Big enough. Thank you. So I've got a Docker file. I'm importing from an image. I've got a bunch of labels on there. You can sort of ignore everything except the labels. I've also got, so I can do, let's see, daylight. So I can lint that. And it's showing me the checks it's running. There's only a few checks here. Label vendor should use a namespace based on reverse DNS notation. I ignored one of the guidelines, so vendor equals blah. So I could break up a bunch of other things, but I think the linting is the least interesting. Following these guidelines is a good idea, but it should just be assumed. I'd prefer actually the Docker build tools to just impose those things. More interesting, hopefully, is the JSON schema. So we can see at the bottom here there are a few required fields. We've also got, we're basically saying that well, there should be one called com.example.version, and that should be an integer. So if I put in Brian as the version, it's going to fail. So well, the makefile is basically just running lint and validate. So I could just do, and actually my Dockerfile is valid, but let's go break it and demonstrate this. So the version was, let's actually, let's use Brian. So hopefully, so again here, it's obviously exited with a sensible X code. I wasn't actually doing a build after that. I was just echoing Docker build in the makefile. So the intention here is you can add this as part of a pipeline, and it's giving you information about the fact that your labels were wrong. This is again like more of a demonstration of an idea than a particularly polished implementation. But I do know some people who are already using this, and ultimately you could read. And like this is written in Python, and it's probably like tens of like it's probably 10 lines of Python or something. You could rewrite this in anything. My interest is like, could we agree on JSON schemas? And yes, if we end up with like many validators, who cares? We've agreed on the schema, and we can share those schemas. I'm more interested in the data. So all I've talked about so far, though, has been build time data. It's all about it. It's at that moment where you're building something. But with containers, one of the things that was discussed quite a lot in the panel for those that were here yesterday was one of the things that is forced by the use of containers is very much a distinct build and a run phase. So if we've got like with these tools and with this idea of sort of image labels, we've got things at build time, but what does runtime look like? And my forced analogy here, when people say containers immutable, shipping containers, like analogy, we need to follow this through, is to bring up the case of the refrigerated shipping container, which exists, which is not a fabrication of my mind. There are many of them. And ask that question: what temperature is a refrigerated shipping container at? And the answer is it has runtime state. This is not an immutable container. This has systems and processes to enforce things or change things as needed. So there isn't really a formal way of doing some of these things, but there are low-level hooks. And I think one of the most interesting is the use of basically, well, Docker exec or similar, or the Kubernetes exec commands to basically both discover and build an API for containers that are running during runtime. So for those that aren't familiar, Docker exec basically allows you to execute a command in the context of a running container. So you're not SSHing into a remote VM. You're executing a command within the context of the C group in the namespace. So what do I mean by this? What's an example of that? So here's a simple Docker file. I'm importing from Alpine, which is sort of like a small Linux. I've added some labels. And when this container builds, it installs bash and then copies the Docker file in. But what I want to focus on are the two labels. So I prefixed them with net.more-than-7, basically, which is my domain, but you can sort of ignore that bit. It would be potentially interesting to look at global namespace standards for labels, but that's a different conversation. The idea is the bit at the end. So basically, we've got .docker file. And one of the things that's capable of there is that's saying where the Docker file is on the running container. And that's useful in my view, because if I have a container, it is running, I am the operator. How the hell was that built? Is a good question. And if the answer is go and find whoever built it when they built it and see if they can work out, it's like, that sounds no fun if I'm like running, like I'm an operator, like at whatever time there is a problem. So embedding that there and having a discoverable way of finding it it's not just that someone randomly put it on disk. They told you in like basically the API in the labels where to find it. So you could build tools on top of that. Show me all of the Docker file, like diff all the Docker files for all of like for this container and this container. Would totally be possible based on purely discovery based on this sort of API. Exec.packages again is saying, well, here's how to find out the list of packages on this machine, on this, or rather running in the context of this container. The reason that's interesting is, well, how to do that is different depending on the base. So maybe you know like the command to run for like dpackage or for apt, but you don't know the command to run for yum, and you definitely don't know the command to run for alpine. And suddenly developers are pushing images with all sorts of random operating systems. But at least here, they're telling you how to get that information out. We're separating the how and the what with an API for our containers. And we can discover this. As I said, like just using the inbuilt tools or just using the API, we can discover that API. So, no, like that question of how do like I have a container, like what the heck is this? What's the like? How was it built? On the machine that's running, on the system that's running, I can discover and then run the command. This is obviously a very low-level example. You could wrap higher-level tools, and I'll show some of that later. But I'll do a quick demo of this working now first. So I have no containers running, but I do have a few images. So I've got an Ubuntu image and an Alpine image, and let's have a look at the Docker files for both of those two. So very simple, strip down. Like from Ubuntu, we've got again the Docker file bit. Like that's where the Docker file is, and we've also got a how to list the packages. And if we look at the Alpine equivalent, we've got the same two labels. And imagine that they had to be on all the images, because we had a JSON schema validating them. You can sort of see how people are just like, oh yeah, cool, I'll add those things. So to get the list of packages on that Ubuntu one, well, I looked at the Docker file, but I could have looked at the labels. And I can just do Docker run, or I could do exec if I had a running container. But let's. So maybe as a nicer example, like for those containers, I know where the Docker file is because the API tells me, the label tells me. I can discover that by just looking going on the machine and typing inspect. So that will do. So it's like I go on a machine, something is wrong. I can pull out where the Docker file is, and I can then look at the Docker file at runtime. I don't like. Yes, you should have a build pipeline. Yes, you should have like standards and systems in place. But at runtime or operations time, this is, in my view, useful. And this has the same API for my Alpine image as well. So that's one example, or two examples with sort of the list packages one. But you can imagine building up, what are the things you would want to know at runtime for a container? Have a schema that ensures there is a label that tells you how to do that. Ideally programmatically, ideally that could be programmatically discovered, as opposed to just, there is a README over here, go read it. And I'll come back to an example in a moment where we actually use that to do something at a high level. I'll keep this actually. So for ideas in this space, I think one of the people who's wrote most about it is Ari over there. So you should totally say hi to Ari and ask his opinion. I think we've done slightly different things, but for the same reason. Building APIs for containers at runtime, I think, is an interesting place. And the reason why I want APIs for containers at runtime is so I can have not so I can have an API, but so I can have tools built on top of it. So remembering that those package tools, remembering the tools we have with yum and dpackage and apt-get that allow us to do the job of an operator. So someone could build a discovery service. Where are the playbooks? Where are the emergency response? Who owns this? Where is the documentation for this container? I need it now because it's on fire. Having that built into the API as opposed to searching GitHub for whichever repo things came from sounds more fun. License verification, boring but important not to get sued. If your legal department turns up and asks about the license position of all of this random software people have put inside black boxes, actually enforcing that there is information about that license at the container build time and being able to query it and being able to ask the question as opposed to going this is going to take a while, at which point the lawyer's like, oh, you mean you don't know? And it's we can find out. Being able to do that quickly is, I think, useful. Links to source code and release notes mentioned about the Docker file being an example, but there's lots of other source code that goes in. How did it get there? Where did it come from? Shortcut the sort of need to ask people with an API. Automatically generating interfaces would be an interesting idea as well. And one of those little interfaces that I've built as an example is actually just package search. Because sometimes there's a certain package, and sometimes that package has a security problem, and someone comes along and says, so are we running any versions of OpenSSL that are insecure? And in the world of system packages, the answer is, I will just ask individual machines. With configuration management tools, often you're storing all of that individual machine data in your CMDB, like PuppetDB or whatever, and you just ask that. In a world of containers, unless you think about it, the answer is, huh? So I'm gonna run up. So all I'm doing here is launching a bunch of containers. So let's run a few. I'm running. So hopefully I've got 3 containers running. 2 of them are Alpine ones. One of them is an Ubuntu one. And all I've built here is based on that API we looked at, based on that those labels. I just built a little search engine. So I'm just running a script there to index that. Obviously, you could hook that off the Docker event API and do make this into a real thing. But I've now got a little package search engine for all of my containers. The package search engine knows nothing about Ubuntu. It knows nothing about Alpine. It knows nothing about CentOS or any of the operating systems. It just knows there is an API from which it can get a list of packages. And so this is searching across Ubuntu, and it's searching across Alpine. And we can see the versions for different packages. No. There's probably other things we can search for. Well, actually, yeah, I think that works. Yeah, so I could list all the packages and all the containers. So again, there's very little code in this. It's a proof of concept, but we could build lots of high-level tools like this, literally just by agreeing on API standards, which I think is powerful. And we actually know some of the tools we want from. Literally just recreating the system package tools would be valuable in most cases. Most of them have a corollary with containers. So, like in conclusion, like metadata is awesome. I think there's a whole bunch of sort of avenues of investigation, including hopefully some of the ones I've talked about, but also others. And out of it, we get the ability to run containers in production. I think to get there, we need to share schemas and namespaces, not just do all of this inside small organizations or inside big software vendors. Over time, we need to build agreement, find out what works, find out what is palatable to more people, and we need to build tools on top of it. They'll start out with a small hacks, but over time, they'll become the de facto way that we manage containers in production. And from that, we can extract actual standards that make sense for like people to adopt for building more interoperable tools. So hopefully that's been useful and made sense and a good start to the day. If anyone's got any questions, have we got time for questions, Chris? I've got time for a couple of questions. Any questions? Well, one here. So the question now is basically if I was given supreme power, what do you mean given? I already have that, surely. Yes. I seized supreme power and was able to impose some labels on everyone. What would they be? I think like version is a good one, partly because versioning is really hard. And actually, if you look at the example labels that people do use, version and creation date are often in there. The number of different spellings or different namespaces or different capitalizations of those is just like means that none of this is interoperable, and just starting there would be a good idea. Saying like, well, so actually you're probably already using creation date and version. Here is the schema that you're using for that. Here's the capitalization. This is how we spell version. This is the namespace it's in. So probably those two. Oh, question over there. So the question there is the example I showed for like listing packages actually executed a command I didn't show the shell script for listing packages on Ubuntu. It's novel and interesting, mainly because I wanted the same output as the APK Alpine thing for my demo. But the question there is, I did that. I ran commands. That's one way of doing it. What about also having like just a static manifest? Because actually, you know the packages on that machine at build time. So, two things. One is you know packages on that machine at build time unless someone changed them after build time. So it's the manifest is only useful if your containers are run in like read-only mode, and you can't enforce that at build time. The other thing, from the point of the tooling, it doesn't matter. Those things could have been actually at build time run those commands, output it to a file, and the API says just cat that file. From the point of view of the tool, it's the label on the API that matters, and to a degree, the how is an implementation detail for the builder. Manifests would totally work if your containers were always run in read-only mode. Most people don't run their containers. Most people who talk about immutable infrastructure don't run read-only containers, alas. Can I comment on tags in the Docker Hub? Yes, tags are a good thing, and I think the only in part of this they're less standardized. They're more proprietary. They're further away. They're queryable, but they're only in the context of the Docker Hub, and rather than being local. I think local metadata is probably more useful in most cases, but there's definitely tools like all metadata is useful. It's like you could build tools on top of the tags in Hub that you couldn't do it elsewhere. It's not as local as the stuff I've been doing. So question there obviously around how to deal with inheritance if you're building up a complex hierarchy of images that are based on other images. What happens to the metadata? I think again that's one of those things where like standards help, because if you're imposing a schema at all levels, or at least the entry point to your organization, you can ensure you're overwriting all of the labels that do differ between those things. But I think like for the most part, the building complex hierarchies of container images at the moment is a nightmare anyway. I think you're better off keeping those hierarchies as flat as possible, because label overriding is not the biggest problem you run into with like deep nested hierarchies in my experience at least. Yeah. I'll say this. Yeah, so for those that can hear, so Ari, who I mentioned previously, the post people should read. What Ari's been doing is nearly akin to what David was talking about. Is actually some of that discoverability and some of that like that API or the responses for those APIs are actually, it's a file on disk, it's a manifest. At which point it's always at the same place, and you can override that file in later layers or in later images. So that works too.
Thanks, Gareth. We'll have a short break. At 10 o'clock, the parallel sessions will start again. I've been told there's a smallish problem with the water supply in the main building, which could cause some problems. Well, the thing is there might not be water at the moment, which also means that they cannot brew coffee. So we're trying to fix that. It can already have been fixed, but that's just an upfront warning.